All right, let's just jump right in. We're about to tackle one of the most just absolutely mind-blowing ideas in all of physics. What if I told you that our entire three-dimensional reality, everything you see and feel, might just be an illusion, a projection, coming from a flat two-dimensional surface somewhere far, far away? It sounds crazy, I know, but we're going to unpack where this wild idea really comes from.
So let's just put the big question right on the table. Is the universe a hologram? Could everything we know, everything we touch, everything we experience, from the device you're watching this on to the farthest star in the night sky, could it all just be a really, really sophisticated projection?
And look, let's be real. Your first reaction is probably, that sounds like something out of a movie. And you're right. It totally feels like an idea ripped straight from the script of The Matrix. It's a classic sci-fi trope, right? The idea that our reality isn't what it seems.
But here's the twist. This isn't just Hollywood make-believe. This whole crazy concept actually has its roots in a massive scientific debate, a high-stakes clash between some of the smartest people on the planet. And it all kicked off with a deep cosmic mystery.
Yeah, that mystery is all about black holes. You see, to even begin to understand the idea of a holographic universe, we have to go back to the puzzle that black holes created. I'm talking a riddle so deep, it almost broke the laws of physics as we know them.
So back in the 70s, the legendary Stephen Hawking drops this bombshell. When something falls into a black hole, all the information about it is just gone, wiped from existence. Well, this started what physicists literally call the black hole war. Other brilliant minds like Leonard Susskind fired back, saying, "No way, that's impossible." Because a fundamental rule of quantum mechanics is that information can get scrambled, sure, but it can never, ever be truly lost. And this right here is the heart of the problem. It's called the information paradox. You've basically got the two titans of modern physics, Einstein's relativity and quantum mechanics, in a total standoff. See, relativity seems to say that information that falls into a black hole is just poof, gone forever. But quantum mechanics has this one unbreakable rule: information can never be truly erased from the universe. So, yeah, they can't both be right. Something's got to give.
Which leads us to the billion-dollar question that had scientists scratching their heads for decades. If the information isn't destroyed, but it can't get out from behind the black hole's incredible gravity, where in the universe does it go? The answer to this question is what turned physics on its head.
And that mind-bending answer has a name: the holographic principle. It's a completely radical, totally counterintuitive, but surprisingly elegant solution to the paradox. And, well, it's the key to this whole explainer.
So, Leonard Susskind, one of the guys who challenged Hawking, came up with this wild idea. He basically said, what if the information never actually goes inside the black hole at all? What if it gets sort of smeared or imprinted on its two-dimensional surface, on the event horizon, that point of no return?
Okay, to get our heads around this, let's use an analogy we all get. Just picture a simple television screen.
I mean, what is a screen, really? It's just a flat 2D grid, right? It's made up of millions and millions of tiny little dots, pixels, that can change color. It's got height, it's got width, but there's no actual physical depth to it.
And yet, when all those 2D pixels light up in just the right way, they create this totally convincing illusion of a deep 3D world. You see landscapes stretching to the horizon, characters moving around, a whole three-dimensional scene all coming from a completely flat surface.
So here's the kicker. The holographic principle takes that exact same logic and applies it to, well, everything, the entire universe. It suggests that all the information that makes up our 3D reality could actually be fully encoded on a distant 2D surface that surrounds us.
And this is where things get really, really strange. Because if this principle holds true, what does that actually mean for us, for the reality we live in? Well, it leads us straight down the rabbit hole to the idea of a simulated universe.
So, the logic kind of goes like this. Step 1, a 3D black hole's information can be stored on its 2D surface. Okay. Step 2, well, if that works for a black hole, why couldn't it work for the whole universe? Step 3, that would mean our 3D reality is really just a projection of 2D information. And step 4, a reality that's built entirely on information. I mean, come on, that sounds a lot like a computer simulation, doesn't it? Now, you're probably thinking, okay, if it's a projection, where are the pixels? Why can't I see them?
Well, the theory says the resolution of our universe is just staggering. The tiniest possible pixels of space would be at something called the Planck length, which is, it's trillions upon trillions of times smaller than a single atom. So to us, reality would feel perfectly smooth.
So this brings up the big existential question, right? If we're living in a hologram, does that mean it's all fake, that my life is a lie? And that's a fair question, but it's really important we get clear on what this theory is actually saying and what it isn't.
Okay, let's break it down. What this theory is, it's a powerful mathematical model. It's a possible way to connect the dots between our big theories of physics. What it is not proof that we're trapped in a video game run by some advanced civilization. It suggests that reality is, at its most fundamental level, information. But that doesn't make your life or your feelings meaningless. The universe is what it is. This theory just describes it in a new way. Your reality is just as real as it ever was.
And we have to remember, this is still the cutting edge of theoretical physics. As beautiful and as powerful as the math is, the holographic principle is still a groundbreaking idea, not a proven, established fact. Scientists are actually working on ways we might, just might, be able to test it someday.
So, why do we even care about such an abstract idea? Well, because it's not just some philosophical game. This thing could potentially solve some of the deepest paradoxes in all of physics. It hints at a profound connection between gravity and quantum mechanics, the holy grail of physics. And of course, it completely changes how we think about what reality and what information even are.
Which leaves us with one last massive thought to chew on. The theory might describe our universe as an elaborate projection of information, but it also leaves us with this huge, tantalizing question that physics might never, ever be able to answer. If our universe is a projection, who or what is running the projector?